Alright, hi everyone, you're welcome to my YouTube channel City of Electrons, and in this video we are going to talk about the transfer function representation. Okay, so recall that from our previous video we talked about the properties of a transfer function, and now we are going to talk about how we can express the transfer function like a general expression. So we know that it's y of s over x of s, output over input, we've said that already, equals k. What is k? Of course, k is a constant. Okay, so all the constants here, we'll talk later. Okay, but here, good. Now here, what we have here, s minus z1 multiplied by s minus z2 dot 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 s minus zn, that is z2 z3 z4 z onto zn to the nth z. Okay, so all these are just roots. All these are roots. Similarly, for our denominator, we have same movement or same pattern: s minus p1, s minus p2, s minus p3, p4, p5, p6 onto the nth pn. Okay, now why we use z for denominator, we use z for numerator and p for denominator, because for the roots in our numerator they are called zeros, while for the denominator they are called poles, so you have p there. So all these roots, we can just represent all the roots. Instead of writing s minus z1, this minus this is, we can just write bs. That's it. So b of s represents all the roots for our numerator, while a of s represents all the roots for our denominator. Okay, that's what I've just said here. Where b of s are the roots for numerator, which are zeros, polynomial, and a of s are roots of denominator, which are poles, polynomial. Note that when a transfer function is represented in the form above, if we write a transfer function like this, we assume that there are no common roots between m and n. Remember, we said in the previous video that m and n is just numerator and denominator. Okay, so when we write it like this, we just assume that there are no common roots. Nothing in the numerator is common to the denominator. If we have something common, guess what's going to happen? They'll cancel out. Okay, so if we have something that's common, they will do what? Cancel out. That's just all you have to bear in mind when we express it like this. Now, when we carry out calculation, you will begin to see how beautiful these ideas come into play. For now, just bear this in mind. Okay, so now there are some examples I skipped. If you have the notes, the complete notes in class, okay, just a simple reminder, this video series, like I said, it's recap of what was done in class. So class recap. So I'm actually using my class notes, what I've written down in class, of course with some other materials, but mainly what we've written down in class. So when I say I'll skip some example, for those that have the notes, you understand what I mean when I say I'll skip some examples. That's because most of the examples, they repeat themselves in more complex examples. So a simple example now I can give, if I do that now, when I get to the complex example, I will repeat that same process in the complex example. So instead, and based on time, our exam is really close now. So based on that, I will skip some of the examples, and then when we get to the complex example, we'll do all in one, or all in maybe two examples or one. Okay, so that will be all for this video. We just talked about how we represent a transfer function in this general form. Okay, so thanks for watching, and share, like, comment, subscribe, click on notification bell also. So I'll see you in the next video. Thanks for watching. Bye for now.